So good morning, ladies and gentlemen. Welcome to this morning's panel discussion on soldering automation, the challenges and the benefits. Wave soldering has largely replaced selective soldering, and manual soldering is currently being replaced by robotic soldering. When does it make sense to introduce these systems, and what are the challenges and benefits? Joining me here to discuss this, we have Ken Takahashi from Japan Unix, Michael Gouldsmith from Thermaltronics, and Tom Berx from Kurtz Ersa. So welcome, gentlemen, and thank you for joining us this morning.
Thank you, Trevor.
Thank you
for having us.
Good. So I'm going to start very quickly with my first question. I'll put it to Ken at the end there. What are the benefits of implementing a robotic soldering strategy?
The soldering robot, as I would say, for contact soldering robot is about 40 years history. Then being like a more automotive section, and then for all the customer. But anyway, so the soldering point is became as a more like a major product to be replaced to the hand solder.
Right.
Yeah.
Okay. Okay, Michael, you've been at both sides of this argument because you have got hand soldering systems. You've got you've more recently moved into robotic soldering. What do you think are the key benefits that customers are seeing out of this?
Well, I think that robotic soldering provides you the things you need to start thinking about in Industry 4.0: accuracy, repeatability, and traceability. And although hand soldering will still remain, we are seeing more and more advances in robotic soldering because you cannot get that accuracy, repeatability, and traceability with a hand soldering.
Right. Okay. I mean, Tom, you're working in robotics in other areas in terms of selective soldering, other robotic systems. Do you see robotic soldering being a big part of your future?
Well, what we are doing as Ersa, we have the whole range of products. So Ersa was the inventor of the electrical soldering iron about 100 years ago now. And we evolved from hand soldering to wave soldering and now a lot of selective soldering. And the selective soldering machines that we produce are now about 25 years that we're doing this. And we see, of course, there are differences between robotic soldering and selective soldering. I think that our benefit is that we, in most cases, are a lot faster, and the accuracy and repeatability can be a lot easier, and of course traceability as well.
So you think, depending on the volume of soldering points that you're doing, and the volume you're doing, it makes more sense to have a selective soldering strategy?
In my opinion, probably the gentlemen have another reason,
feel welcome to challenge this.
Another thing about it. But I think if it's going to speed, then yeah, I think selective soldering is a lot easier. It's not always possible. That I agree. Yeah?
Yes, it's not always possible, and I think where robotic soldering comes into place, where selective soldering cannot play, is when you have 3D devices to solder. If when in an application where you have a motor housing in which the board is dropped into the housing, there's no way that you can selective solder the final data input terminals or the power terminals. It has to be done either manually or by a robot, and a robot will do it more accurately, more repeatability, and more traceability. That just cannot be done by...
So do you see it in a supplement to selective soldering, that if you're doing a lot of volume, you put it through the selective system, then afterwards go after the large odd form devices or sensitive devices with a
yes,
robot?
there are certain components today which are heat sensitive and can't go through a selective or a wave.
Yeah.
And while I would certainly agree that in certain applications, selective soldering is going to be faster. But as technology advances and electronics moves into almost every area of our life, selective soldering is not going to be the answer in every case.
Ken, do you have a view on this?
Yeah, basically agreed with him, and a lot of selective components that we call as like a heat sensitive components, which they couldn't go through, and some selective wave solder. That's our main target to do the robotic soldering. So for the output standpoint is we could do some a little more like unique technique like a drag solder to be meet some like a better cycle time. Yeah.
And is it easier, I guess, to extract data from a robotic soldering system as opposed to selective, where you're doing the whole board?
Data we can get out, but I do agree with this gentleman that in a lot of cases, of course, with selective soldering, we need to come from the bottom. We have gravity. With the robot soldering, you can come from sideways. There are parts in motors that we cannot solder selectively, or people need to have a very, very special carrier, which is not always possible. I think that both technologies will be used. Yes. It's depending on the kind of products that you need to produce, depending on the kind of speeds from time to time, but I think that both technologies will exist. And of course, even if we are a very strong partner in a very strong force in the hand soldering, the robotics, the selectives have the traceability issue, and of course the repeatability and the accuracy that with hand soldering is very difficult to achieve.
Right. Okay. Ken, what do you think are the benefits between laser-based soldering and the other types of robotic soldering where you're trying to emulate the human soldering action?
I would say the laser became our more popular. Where like our product is actually been about 17 years from the launch the laser system, and then we talk about some more like a traceability standpoint. There's a lot of data, and then we can control everything about the number of the input output, and then especially like a internet thing is like 4.0, and they prefer that some MES system stuff, and we could do all the data backup and sending and uploading, and the customer prefer that kind of control. The solder tip, I would say contact solder method is still very good. I mean, we have some many are same traceability option. However, they got some like a little worn out after a couple hundred shot, and then there will different the shape the solder tip or temperature dropping or something like that. So that's why one of the reasons is a laser became more popular.
So are you using one of these lasers where you're combining the sources to be able to reduce the overall the heat that's getting to the area, so it's not burning the substrates and devices?
Yeah. So we can control the beam shape and size, and then of course there's a lot of a fixture will be involved too. Mm-hmm. But all the parameters thing is that we built about 17 years. So.
Right. Now, Michael, I know you're going to have issue with that.
What?
I know you're going to have a different opinion to that because.
Well, I do believe that there's an opportunity for laser soldering, but from the laser soldering that we've seen today, there is as much chance of getting a failure as there is of getting a good solder joint. And we believe there are developments out there in terms of the solder beam itself that will provide a better solution, and we're looking for a more consistent solution. From what we've seen from current lasers, they're sometimes a little bit fierce. I know, Ken, you can control them, but in some of the boards that I've seen, particularly on flex circuits, some of them have been hit, and right. There's a hole in the board, so that's not good. So it's certainly a way to do the soldering process, and it will become prevalent in the future, but I don't think we're quite there yet.
I mean, there's a lot goes into creating the right intermetallic solder joint.
Yes, well, one of the IPC standards is that a typical reflow solder process is between 2 and 5 seconds, and when you're using a laser, it's bang. And we're not always sure that you're going to get a good solder joint. You could get a joint that's brittle and may not be visible immediately, but 6 months down the road, you've got a cracked joint.
Right. Okay. Tom, do you have a view on that? Or?
Well, we don't come so much in contact or in competition with laser soldering. The only few times that people came to us that were using it is what my colleague here says, that they had some security issues.
Yeah.
Yeah. So what I got is that the percentage of let's say first yield was very, very low. So that people said, we come to you because we believe this is also possible in another way, and we want to have a more secure way. But I have to say that it's rather unusual to get this question for us.
Right, okay. Okay, let's go back to Ken at the end there. Got a question here. What are the benefits, why use a track system on an inline robot instead of an arm system? Does that make any sense to you?
I think that was probably me, actually.
That was you who gives that question. I'm not sure I fully understood it, so maybe you can explain it.
Well, in addition to our standalone robots, we now have an inline system.
Yeah.
And when we were thinking about the design of the inline system, we were thinking about how to transport the board from one location into the solder robot. We did look at robotic arm solutions, but in the end decided that a track system, as used in a standard SMT production line format, was far more suitable, because robotic soldering, as I said, tends to address many of the things that Selective cannot do. And as such, the parts themselves are various different sizes, shapes, and weights. And in that regard, we felt the track system was a much more autonomous approach, rather than having to have so many different robotic arms to move it. So we chose the track.
I see.
Sorry,
I understand where you're coming from now. Okay. Well, I'll move on. Well, my next question really is we're moving into an area where we're going to have a lot of 5G coming down the pipe. These are large, heavy boards. What is the best way to maintain accuracy on these large boards? I'm guessing selective soldering is going to be one of them.
Yeah. We are already active in this field. We have a few customers in the 5G antenna production, and they have massive boards. Yeah, so we have developed a machine quite recently that can handle boards up to 3 meter length, 3 meter length and 600 millimeter width. So we have sold several of these machines already. And we can have the same kind of accuracy with the axis, 0.2 millimeter, with the Parker axis that we use in the other system. I also want to pick in the previous question, because in the beginning of selective soldering, let's say 20, 25 years ago, there were some of our competitors who were using some kind of a robot arm. But what you see now is that we have offline machines, but the majority of the machines that we are selling are inline solutions with conveyors that can be connected even with SMD conveyors, what you see in a normal SMD line. And we have their solutions for products, for small boards, for big boards, for heavy boards. So that's the way that we see that this is evaluating now.
That's the best way you see for the industry. Ken, what's your view on how to maintain accuracy on large boards when you're doing robotic soldering?
The large board is always actually challenging for that. The handling, we do have actually kind of a limited stroke of the robot, which is now more getting popular. My gantry robot, which is traveling about 600 mm square. We could also like a little bit, the question we talk about is some track system, or might be just extended some cylinder to be able to accommodate for the area that we need to cover that. Yeah, but basically between 20 to 30 micron, that's our accuracy. That is that we are currently using for robot ward. Yeah, that's how.
So 20 micron accuracy, did you say?
Yeah, 20 to 30.
20 to 30, okay. Interesting. Michael, how do you maintain accuracy across these large boards?
Well, for us, we use probably a slightly different approach in that we use vision, mapping, fiducial marks. We have dynamic laser height control. So the size of the board is not so much a challenge, because particularly because when you're using fiducial marks, if there is any slight variation from one board to the next, the system will automatically compensate for that variation.
Right.
So we can maintain accuracy very, very well.
So that would include warpage and stuff like that?
Yes, because we have dynamic laser height control. So the laser is ahead of the actual soldering process. So if there's any warpage or there's any change from one board to the next, the system automatically again compensates for that warpage or change.
Okay. Tom, how do your selective
Yeah,
systems-
what we do is partly the same. So what we have the high accuracy and repeatability of the machines and of the access that we have. And then, of course, we use fiducial technology as well. And also we have warpage solutions where we will measure certain parts of the boards, and the Z height can correct the height difference.
Right, okay. And you're doing a similar system too. Okay. So my next question goes back onto robotic soldering. Do you feel that are they suitable for a high mix environment? I mean, how quickly can you program your systems?
I think it's a very good question. Is of course based on, I don't want to say that, but it depends on the number of the joint you have, and let's say the high mix and low volume that we are currently facing. That's why it's the more industry is booming about the benchtop, more like a batch offline system. So we can pre-program installed at each application board, and then we'll change over time. Is I would say just a few minutes.
Okay. What about you, Michael? In terms of a high mixed environment and programming, how do you automatically program yours? Or
Well,
do you have to-
because we don't use a teach and learn pendant. We do because we're using camera to take a picture of the board. We're programming the board process live,
Right.
and it ensures accuracy, and we can take a before and after picture and even measure, in certain cases, any voids that have occurred in the process, and therefore be pretty accurate, actually.
Okay. Okay. Same
I can
question.
answer the same question,
You
of
can
course.
do.
Yeah.
You
So
can do.
What we do, so we can program the board offline, so the machine can run on a different product. We can come from ODB++. We can take a scan. We have the high flexibility. We have always several modules in the machine. At least you have a fluxing, a preheating, and a soldering module. We have machines up to 12 modules, and every module can have a different product.
Right.
As long as the width is the same, that was until recently, and now even we can have different widths in different modules. So the flexibility is now huge.
Right. Okay. So moving on, I think this is going to be my last question of the panel. How does your machine meet Industry 4.0 standards? I mean, can you take data off of it and collect the data? What other things can you do to meet the Industry 4.0 requirements?
Yeah, I a little bit explained about this IoT 4.0 in previously, but we do have some very own software, which is robotic soldering is required. The customer demanding about the temperature profiling, all the 4-axis coordinates, and then all the our parameter. Certain amount of speed or time is all kind of detail information, so we could track all the data and saving, and then again is uploading to the MES. This is what we have.
So you can do that by point. You can monitor every soldering point.
Yes.
What temperature it was
Yeah,
used.
once the
dwell
trigger
time.
hit the operation mode, then we'll be automatically saving all data and each start buttons and programming each board.
Okay. Yeah. I mean, Michael, this is an important area because increasingly Industry 4.0 is demanding traceability. So people need to know exactly what was soldered at what temperature, so they could have full traceability in case of recalls.
Yes, absolutely, and I understand exactly what Ken is talking about. In addition to those features, we also use a soldering technology which employs Curie point. So Curie point is absolutely the best way to control temperature.
Curie point?
Yeah, Curie point.
Curie point.
Yes.
What is that?
Curie point it's named after a physicist called Curie. Curie discovered that every magnetic alloy has a point when heated that it loses its magnetism. So by using that phenomenon, we create soldering tips which cannot go beyond their set temperature. So from a temperature profiling point of view, we are very, very accurate.
Okay. So you physically can't damage the
You
joint.
physically cannot overshoot the set Curie point.
Right.
So there is no overshoot, there is no undershoot. So it was a patented technology, and the patent expired about 10 years ago.
Okay. Good to know. Tom.
Yeah, we are working, of course, with solder pots. So in our solder pots, typical solder pot has about 13 kilogram of alloy, and we control the temperature by 0.1 degree. So we cannot overshoot, we cannot undershoot. Yeah? And the Industry 4.0, of course, we are ready with all the traceability data. You can have the complete videos of what we are soldering the whole time. We have, with a lot of our bigger customers like Bosch, Continental, we have a specialized MES system with our machines for their technology, for their software. So we are very far in these things.
Great. Well, it sounds, gentlemen, that all your systems seem to be coming on in leaps and bounds. It's definitely a growing area and an important one, which is helping to maintain or increase the reliability that we're getting off of our systems. So I want to thank you for joining us today. Ken Takahashi from Japan Unix, Michael Gouldsmith from Thermaltronics, and of course Tom Berx from Kurtz Ersa. Thank you for joining us today.
Thank you, Trevor.
Thank you,
Thank
Trevor,
you.
for having
Thanks.
us.